back to 380. In a previous video, which you can see on the left here, I had went through and modeled a stub shaft, basically a sort of end of shaft based on a hub. Now we made some fairly arbitrary decisions, like for example the inside diameter and all that sort of stuff. One of the things that we often wonder about is this ring. It takes quite a bit of side load to bend this out, snap it out. There are other ways of holding our hub in place though. One way is to use what we call a shaft nut or a bearing nut or a bearing lock nut or shaft lock nut and all this sort of stuff. What I'm going to do here is go at it kind of in a strange way, place it first and then modify the shaft to fit the nut, which we'll see in a second here. We'll download it from McMaster-Carr again. And I'm starting a new file. If you're following along from the previous one, you can save a milestone and continue on, or create a save as or whatever you wish. From now on, we'll just work away on this one. For those who are joining for the first time, there's an analysis here showing just the portion, and again we can see our ring here. I'm going to try and replace the ring with a shaft nut. So as before, let's just go up to McMaster-Carr. How does it look? So I'm going to kind of do this interactively here. Shaft nut. We're in metric here, so let's go straight to metric. Thread type, you can see trapezoid like this image here. We're just going to go to metric, standard thread. Again, there's a lot of options in this. One of them is, what does it look like? So you can see a chamfer here, stainless. Further down, there's other options. Looks the same, but with less backup. Lots of sizes, obviously, because we've got lots of shaft diameters we can use. And then thin profile. These usually go in pairs, as far as I can tell, or they sit behind another step face. For us, we're going to go for this first one here. The advantage of these guys is that they don't need a washer. So, for example, over here, we can see this type, a chamfered face, needs the nut itself, the bearing nut, and a bearing lock washer. I'm going to go ahead here and just use the first type, which is it's a one piece. It's got a nylon insert as far as I know. Where are we here? They're not very heat resistant, which is a problem. So if you want heat, these are a no-no. Basically, we're just going to use these. Now, the question is, what should it look like? I had to look around the web trying to get an idea of what was going on. This image seems to come from, I'm not quite sure actually. It's a Japanese website. And we're seeing a lock nut here, essentially. This is for a bearing, but we can use it on in our case, a hub, I suppose a sprocket. Notice that it's chamfer up against the part, so we're going to keep that in mind. And we can see here that we've got a washer, and what happens, the washer goes around the chamfer, and there's a little toe that sticks under. We might, maybe we'll do a third video, which is how to place these guys. But for now, just going to go ahead here and go with the bearing lock nut first. So also, notice that the thread here is more or less sitting right on top of the shaft diameter. In option number 1 here, there's another option which is lower. To make a point here, we're going to actually not extend the key seat out through the hub. We'll leave it as is. and we'll get a full thread for these guys. So we can't use this style because we have no keyway to use, no keyway to fit into. So given all that, let's go ahead here and pick one. Our shaft is 30 millimeters in diameter. Let's use a M30. See how that goes. We come down to one option. It's basically just material. I'm gonna use carbon steel. I'm not worried about rust or corrosion, or we're gonna pretend that it's also spec'd to ISO. So we're gonna go with that one. 60. Well, we can see the number. Let's have a look at the detail. And I'm gonna take a little snapshot here in case I forget something. But it's an M30 by 1.5. It's got a, we can see here, nylon insert. It's perfect. And we'll download this. $14 or so. Again, chamfer in towards the load, or towards what it's holding. Put it into shape. You can see here it's getting a little bit off kilter. Just going to pull it out so I can see what's happening. Say okay. Not grounding it. Going to ignore this, but just hide it for now. See if we can modify this groove somehow to suit our new part. Notice the style of this. They've got quite a big chamfer over the top, so that's something to keep in mind. So let's just joint this in unconstrained first. And constraint second. Let's put it right up against the face of the hub. Might move this later, but for now there it is, looking good. A little short in here. So let's have a look at the sketches while we're at it. Maybe we have to lengthen this out 12. We probably want at least one full thread out. This is a 30 by 1.5, so let's go to 14. Again, if we want more thread, we could decrease this chamfer. So again, up to us. This looks quite good, apart from one significant problem, which is that down here, well, it's not bad, actually, even as is. We see the nows of why they have a big chamfer here, because often we don't want this rubbing on this guy, but I'm going to modify this slightly because you can see we don't have good rubbing here. So if we want to have a thread run out or a groove to let the thread be fully machined through, we're not looking too good yet. So from the previous video, we see this number. This was our groove depth, 28.6. So we're going to modify this groove, just shift it around a bit, suit our part. Now, first though, I have to get rid of that ring. So let's just click that once, press delete. Yep. Just deletes the ring and all of its associated bits. Nice. So now we're down to this. Now we have to thread this face here. I'm going to thread this first so that we can get a feel for sort of type thread. And I want to have, should pick up 30, it's 30 by 1.5. Let's model it so we can see what's going on. Say okay. I'm going to pull it back through the history just after that fillet we did in the previous video so I can move that groove a little bit. So let's edit our sketch. I'm going to turn this over to driven so I can just get a feel for it. And this line is kind of locked in place. Let's see if we can figure out how to get rid of it, get it off. Maybe constraint. No, that's not it. And it's sometimes hard to find. We did lock in the previous video to this mark. So let's just delete the line. Make sure we're working out and rebuild that end. It should be okay. I should remember this. So let's go ahead for a more rational event number, say 2. And right now, where are we positioned? Well, we're not sure. Maybe we can measure from this back end. So let's go from the end of the, or the beginning of the shoulder to there, and we could call it like 34, right in the middle. Leaving this uncontrolled. Right now it's just inspection. Finish the sketch. Seems okay. See here, we're not really taking off the thread properly. We need to be a little bit further down. So we can still grab this now because we're just inspection. You can see here that, well, like what is this diameter, for example? 14 and a bit. So 28's not going to be enough. So we could go 27 and a half, 27.6 right now. So there are some standards for this. I'm not going to try and figure out what that is in the middle of the video. Edit the sketch. Again, depending on who you're talking to at the office. If I could double click properly. Let's go for 27.6. Finish the sketch. Looks fine. Now we've reused our 30 surface, which is fine. That's maybe save some machining time. And the assumption is that this would be fairly easy to slide over. It's not a very tight fit, so the threads should be okay with this hub being slipped over the top. But again, if you discover that it's not, you would have to go to a smaller thread size. We can see it's not a big deal, but this is a little bit off kilter. So we can edit the joint. We can actually just rotate it into place if we want. So minus, looks like minus 90 is going to be good. Going to draw our attention to this subcomponent here. So the bearing lock nut, we have two bodies. Actually just going to make them into components individually inside of this. Now we can see what's going on. So we have a nylon insert that's our that's our locking mechanism. So that's the green in this case. And again, the key slot here gets a little bit in the way of understanding what's going on, but it looks okay, right? Still covering it. On the bottom, we see what's going on. We've got a good contact here, good access, and everything looks fine. There's our threaded end. So if we want to use a shaft nut, this is one way to do that, using quite a big radius, 30. Again, one other option would be to neck it down, step it down, have a smaller lock nut or shaft nut, but then we run into some problems of maybe being a little bit too narrow for the hub. So this is based on, I believe this is NTN diagram right here, and we can see here that it's more or less the same size, the thread, as the shaft that is holding the object. So there we go. That's the end of that. Over to you.